Okay, for today we are looking at dividing square roots. We're going to split this into two separate days. We'll do the easier part today as the online lesson. Tomorrow when I see you in class, we will do some of the harder, more in-depth problems. That way I'm available to help you kind of get through that. All right, so first thing for today we're talking about is dividing. So it's the quotient property of square roots. If you notice in the example in the green box, they have the radical or square root of a over b. To simplify that, we are allowed to split that apart so that we have the square root of a over the square root of b. And then we can kind of treat them as two separate problems. All right, so down here, it is considered simplified when there are no fractions inside the radical. So the first thing we need to do is kind of split those apart. Okay, so we have the square root of 3/4. We can split that to the square root of 3 over the square root of 4, which then becomes the square root of 3 over 2, because we're simplifying that square root right here of square root of 4. We can simplify that to just 2. Okay, looking at our examples here, we'll start with square root of 16 over 49. So always the first thing we want to do is split that. So the square root of 16 over the square root of 49. And then we can simplify. We know the square root of 16 is 4. That's perfect. And the square root of 49 is 7. 4/7 does not simplify, so we are finished. All right, problem number 2. Anytime you see that big fraction, we want to go ahead and split that. So the square root of 2 over the square root of 81. Square root of 2, that's not perfect. I can't do a factor tree. That's just going to stay radical 2. On the bottom, square root of 81, we know is just 9. And then we are finished. There's nothing that can be simplified, so we're done. Number 3, we have square root of 8 on top, square root of 25 on the bottom. We always want to split that giant radical apart, and then we can try to simplify. Square root of 8 is not perfect, but I can do a factor tree on that. So we find a pair of 2's, which will come out. We have a leftover 2, leftovers in the fridge. And then on the bottom, the square root of 25 we know is 5. Now we always want to check to see if anything simplifies. Numbers not in radicals, they can simplify together if you can do anything. In this case, I have a 2 and a 5. That does not simplify, therefore I am finished. Okay, so this section, go ahead and add these to your notes. I apologize when I gave you the packet. These were not in there, but then as I was going through recording lessons, I discovered that I wanted to add them to our packets. So go ahead and find a spot on your notes or a separate sheet or the back side, something where you can add these examples and work through them with me. All right, so number 4, we have the square root of negative 180 over 5. So kind of sticking with what we've been doing, we'll separate that to negative 180 over radical 5. The radical still attaches to both because they were both under it, so they're both going to have still a radical. Now we want to try to simplify our fractions. So always first and foremost, we want to simplify. What I mean by that is I have 180 and I have a 5. I can divide 180 divided by 5. Divides perfectly. So we can simplify. Negative 180 divided by 5 is negative 36. Okay? If you can simplify, divide them perfectly, simplify both numbers, you always want to do that. Okay? All right, from here, I know there's a negative underneath here, so that's going to come out as an I. And the square root of 36 is perfect. That is just 6. So it simplifies to 6i. All right, it's number 5. Right away, I see I have 2 numbers underneath radicals. These numbers can simplify together. They're considered like like terms since they're both under a radical. So 54 divided by 2 is 27. So this becomes 3 radical 27, and there's no longer a denominator since that divided nicely. And then I can try to simplify. So I can do a factor tree on 27. And then I can look for pairs. I have a pair of 3's that will come out. a leftover 3, leftovers go in the fridge. Don't forget that outside number that you already had. So 3 times 3 is 9 and radical 3. So we always want to try to simplify our fractions before we try to do factor trees. Okay, number 6, negative radical 224 over radical 7. So right away I'm looking at these radical numbers and I'm going to ask myself, and I'm going to try my calculator, can I divide those nicely? And the answer is yes. So the negative still stays outside. Dividing those gives me just 32. Now, I divided them under the radicals, therefore they're still under a radical. So now I can try to simplify. I can do my factor tree. So doing a factor tree here, let's see, that's 2 and 16. That's 2 and 8, 2 and 4, 2 and 2. Okay, once we do our factor tree, we look for pairs. I have a pair of 2's. There's another pair of 2's. I have a leftover 2, leftovers in the fridge, and my outside negative is going to come down. And then simplifying, we have negative 4, radical 2. Notice there is no I in this answer because that negative is on the outside of the radical, not the inside. All right, and number 7, last problem for today, so a very short lesson for you to work on. Again, I see numbers under radicals. We want to simplify those first. Now this time I can't divide them perfectly like I had the other problems, but I can simplify. Both of those numbers can be divided by 2. Now again, I am only working on those numbers under radicals. It has to be like terms. So this is very similar if I had given you negative 6 over 8 as just a fraction and I asked you to simplify it. You would divide them both by 2 and tell me that was negative 3/4. Same idea over here. Right? That 2 on the outside, I'm not even touching him, I'm not looking at him, he's just kind of along for the ride. Simplifying, that would give me negative 3, and that would give me a 4 on the bottom. I have not done anything with that radical, so therefore the radical is still over those numbers. All I did was simplify them. All right, now that I'm done simplifying my fraction, now I will try to do something with my radicals. So I notice that I have a negative underneath there, so I'm going to end up with 2i radical 3. Can't do anything else with the 3. I can't do a factor tree, nothing with that one, so it's done. On the bottom, the square root of 4 is 2. Therefore, the radical is gone. Now, I need to look and double check, because I did everything I could with the radicals. Double check your final answer. Can it still be simplified? And in this case, yes, it can. Notice now, I have 2's on top and bottom, neither of which are underneath a radical. These 2's will cancel out. So I'm left with I radical 3. And I am finished. That's it for today. Very short, very sweet, kind of getting the basics. Tomorrow when we are together, we will go ahead and look at the harder properties of dividing with radicals and how to rationalize. So I will see you tomorrow.